All right. This is 10.2. We're going to be doing example 3 where we're finding an equation given the vertices and the foci. So all we know are the vertices and the foci, and we're going to find our equation. So first, I'm going to do a little sketch. I always recommend doing that first when you're trying to find, and when you're just given some points, because it's kind of hard to visualize in your head what these points are going to look like. So yeah. So I'm just going to do a little sketch over here. So my first point is at 0, -2. So 0, -2. I'm going to put the points on in red, so it's a different color. So 0, -2 is my first point. That's one of my vertices. 6, -2 is another vertex. -2, -2 is a focus. And 8, -2 is also a focus. So, right, unlike ellipses, with hyperbola, the foci are outside of the vertices. So that's what we're expecting. That makes sense. And I can kind of do not really an accurate sketch, but I kind of know that my hyperbola is doing that. Wow, those didn't even touch the vertices, but close enough. This is essentially what my hyperbola is doing, okay? So I can use that information to then make my equation. So first of all, what this tells me is that this hyperbola is opening up left and right, which means the first term, the positive term in my equation, is going to be the x term. So left and right, so I know that my x term is going first. The next thing that I want to do is I want to figure out where my center is. So I want to find my center. So the center is going to be halfway between the two vertices and halfway between the two foci. So I can use either set of points to find my center. Because the vertices go from 0 to 6, I'm going to use those because halfway between 0 and 6 is 3. I can do that in my head. I can do that without much trouble. I know that half of 6 is 3, right? So, but for that, no matter what points you're using, you can just use midpoint formula, which is just averaging the 2 points. So since the y-coordinate hasn't changed, then the y-coordinate is still not going to change for the center. And then obviously 0 plus 6 is 6 divided by 2 is 3. So that's where the 3 came from. So I know that my center is at 3, -2, which they found right here, right? So this is the center. Okay. So I know I can start filling in my equation. I'm going to have x minus 3, right? 3 is my x coordinate of my center, squared over something, I don't know what yet, minus, it's always minus for hyperbola, y plus 2, right? Because the y coordinate is -2. So y plus 2 squared over something equals 1. And just like with ellipses, these are always going to equal 1. Okay? All right, so now I need to find a and b to figure out what my denominators are. So a is easy, right? A is the distance between the center and one of my vertices. So the distance from 0 to 3, which is just 3, right? Or 3 to 6, which is also 3. So center is easy. It's just halfway between my two vertices, which in this case is 3. So what goes under, so A always goes under the first term. So the distance from the center to a vertex always goes under the first term, and it's a squared. So if a is 3, I'm just going to write a note that a is 3. which means that what goes here is a squared, so that's 9. That's 9. Now, I don't know anything about B, but I can find C, right? Because that's just the distance from the center to a focus. Center to a focus. So I know that my foci are at -2 and 8, and my center is at 3. So I just need the distance between 3 and -2. So I can just subtract them, right? So 3 minus -2, which is 3 plus 2, which is 5. So C equals 5. Again, I could have done that with 3 and 8, right? 8 minus 3 is 5. So C is 5. And I can use that information to find B. So remember that the relationship between A, B, and C is Pythagorean, and in this, for hyperbola, C is the hypotenuse. So with the ellipses, A was the hypotenuse. Hyperbola, C is the hypotenuse because it's the longest distance of my A, B, and C. C is the longest distance because it's outside the parabola. Hyperbola, sorry. It's outside the hyperbola. Okay, so I know this relationship and I want to find B. So I'm going to rearrange this to solve for B. So B squared equals C squared minus A squared. And then I'm just going to plug in. So I know that C is 5. So C squared is 25. A squared is 9. So B squared equals 16. So B equals 4. Write that over here because I ran out of room. B equals 4. So again, you could have seen that C was 5 and A was 3 and said, okay, C is the hypotenuse, so this is a 3, 4, 5 triangle, therefore B must be 4. If you see that, that's great. If you don't, using the Pythagorean theorem will always work. So B is 4. So B is 4, B squared is 16, so 16 is what goes here. 16, yay. So we have our equation, right? We have our equation. We don't need to find the equations for the asymptotes or anything because we're just looking for the equation on this one. Although if we wanted to find the equations of the asymptotes, that would be pretty simple because we already know A and B. We have a rough sketch. So A, right, is this distance. B is this distance. And our asymptotes would go through this box. So asymptote. This is a rough sketch. If you were actually graphing this, it'd be way more detailed. That's supposed to go through the corner, but you get the point. So the asymptotes would be y equals always plus or minus. In this case, it's b over a, right? Rise over run is b over a in this case, so that's going to be 4 over 3. X minus h, so that's x minus 3, plus k, which is minus 2, minus 2. It's kind of sloppy, but this would be, or these would be the equations of our asymptotes. This question didn't ask for that, but I decided to go through how we would do it anyway. Hope that helps, and I will see you guys in the next video.